Hey, it's Miss Phelps. Sorry that it took me so long tonight to get uploaded. I was spending hours working on my hair and makeup. Sorry about that. Okay, so tonight we're going to be kind of continuing with points, lines, and planes. And as I've said before, points, lines, and planes are the three undefined terms in Euclidean geometry. But tonight we're going to talk about defined terms in geometry. So defined terms are all other terms in geometry. They must be definable, and a definition includes a category and then a list of critical attributes. So you ask me, so what is a critical attribute? It's the things that kind of define it, okay? So let me give you an example. So if I say, for instance, space. Space is a set of all points, boundless and three-dimensional. Well, set of all points is actually going to be the classification. So it goes in the point group because it's either basically a point, line, or a plane. So it's in the point group, and its critical attributes are that it is boundless and three-dimensional. So these are the critical attributes that make this definition different from other definitions. Alright, so we have about 7 vocabulary words tonight that I want to go over with you. The first one is space, and space is the one we just talked about. It's the set of all points, boundless and three-dimensional. The next one is collinear, and I'm pretty sure that we've talked about this several times in class. Collinear is the set of points that lie on the same line. So for instance, if I have this line and I have little bitty points all the way down it, they are collinear. And remember, we were talking about collinear in class, and we said that collinear is kind of like having a co-worker. You're with them. So it's kind of the same idea. All the points are together. Alright? And there's also a hint that 2 points are always collinear. 3 points have to be checked to determine if they're collinear. And if you think about that, I could have a point here and a point here, but if I throw another point over on this side, then it's not going to be in the same line. So that would only make sense. Alright, the next word is non-collinear. And that's obviously just what you would think it is. It's a set of points that do not lie on the same line. Alright, the next one is coplanar. Coplanar is a set of points or lines that lie on the same plane. So just like we were talking about earlier today, that it takes at least 3 points to have a plane, these points are coplanar. Alright, wow, that's a great picture that I have there with that X in front of my words. Not sure how that happened, but you never know. Okay, so the hint with coplanar is that 3 points are always coplanar. 4 points have to be checked, because if you remember today, well, actually we're going to get that page tomorrow. If you have a plane, you might have 3 different points on it, and you might have something shooting through the middle of it. Well, that point down here may not be on this same plane, so they're not really the same. Okay, the next one is non-coplanar, which is basically what you would think, just the opposite of that. It's a set of points or lines that do not lie on the plane. Alright, probably my favorite word is out of this bunch is skew lines. Skew lines are 2 non-coplanar lines that do not intersect. And I think we've talked about this in just about every class. And we said that you could have a line or a plane going this way and another plane going this way, and they never actually cross or intersect, and they're not on the same plane because this one stays up here, this one's down here. A really good example of that would be like an overpass, 2 roads that have an overpass, because that top road is never going to connect to that bottom road. Alright. Next word is parallel lines. They're 2 coplanar lines that do not intersect. So they're on the same plane, so they might be both on this plane, but they're never going to touch each other. So a really good example of that would be a divided highway. They're going to keep going side by side, but they're never actually going to cross. Or railroad tracks. That one's like used a million times. Okay. Now then, intersections of geometric terms. Alright, if you'll notice, my paper does not look exactly like your homework assignment does. I was having a bit of trouble tonight. But down at the bottom, it'll say two lines intersect. Well, I'm sorry, not lines, planes. Two planes intersect at a line. And we talked about that in class today, that if you had a plane, one that went this way and one that went this way, that where they intersect makes a line. Alright? Two lines intersect at a point. So if they're crossing each other, they're going to intersect at one specific point. And the last one is a line and a line and a plane intersect at a point. And I'm not sure if you'll remember this one or not, but I had a skewer stick and I stuck it through my paper and I said, okay, if this is my plane and that's my point, it's actually, my line is going to intersect at a particular point. Alright, that's all the notes for tonight. The one thing I want you to remember and tell me about tomorrow is going to be that, let's see, that the distance is always going to be positive. Okay, and I want my mistake, which is right here, that my intersecting lines are not where they're supposed to be. I hope you have a great evening tonight, and remember, make good choices.